Hi folks, welcome to Dinesh Tech Bytes Fix My Kubernetes Cluster series. In this episode, we are going to solve another problem. We are going to follow the same pattern. Let me share screen and start my new fresh cluster with an issue, and let's try to solve it. Yeah, so the cluster has been created, the pod has also been created, and the pod is in pending state. Let's quickly check that once again. Okay, the pod is still in pending state. Now let's see the how all other pods, the scheduler, control manager, API server, all other pods are how it's doing. Let's do the get pods on all namespace. We see this is pending. Okay, it's a known thing. Then we have everything running, but we see one issue where the scheduler is being restarted 28 seconds ago. This is looks like a similar thing to the previous issue. Let's check the logs of the scheduler. Okay, if you see the logs, it's saying like, okay, unauthorized. If you remember last time in the previous episode, we were seeing an error saying like unable to get pods, unable to list pods. It was able to do authentication, but it doesn't have access to get pods and list pods. This time, it was showing the username also, system : kube scheduler doesn't have access to list pods, doesn't have access to list nodes. But this time, it doesn't even have that access. It is saying unauthorized. So let's see what is happening by SSH into this cluster. So let me do docker ps to know the container ID. So docker exec-it. Yeah, if you are not seeing the previous episodes, why are we doing docker exec for the kind-based Kubernetes cluster will be confusing. So seeing the series from the beginning will be very helpful to understand the context of how this series is been happening. Let me, yeah. So I'm into this control plane machine. Now let me do, so we have this, so as we discussed in the previous episodes, right, we have this manifest file where we have all these static pods, the core components of this Kubernetes are running as in static pods like etcd, API server, scheduler, and everything. Now, if you check out this scheduler, so we have the scheduler, and scheduler is in pod.yaml, and we are seeing for the scheduler, we are saying for authentication, use this scheduler.config file. For authorization, also use this /etc Kubernetes scheduler/config file. But within this pod, how this file is being created or added. Now, if you see here, there will be a volume mount which says, okay, mount this volume. Okay, we have this volume mount, but where is this volume created? So the volume is basically a host path based volume, which means the volume is present in this host, in this VM. So which means in this path. So which means if I do ls on this host path, I'm inside the host. So host Kubernetes scheduler. So we have this file. So this file has been mounted into the scheduler pod. And using this file, the scheduler is able to talk to the API server for authentication and authorization. Now let's quickly have a look at this file. Cat etc Kubernetes scheduler.conf. It's nothing but an kubeconfig file, which is having an list of schedulers. In this case, this only scheduler. Then we will be having a list of users, then list of context. And the current context point to the default. So which means for this user with this credentials, it will talk to this cluster, which is running in this IP. Now, if we try to use, let's say, kubectl get pods -- kubeconfig using this, let me go out of this manifest. Now, the scheduler.config is present in this location, right? Now, let me do kubectl get pods -- kubeconfig using this scheduler.config. It is saying you must be logged into the server. It is not having proper access. But let's say I use some other configuration as a control manager. I'm able to access it. But for scheduler, there is some issue in this scheduler.config file. We have to inspect that config file and let's try to fix that, right? So as we've seen, so we have three sections. One is cluster, one is user, and another is context. Context is nothing but a more of a configuration. Cluster will have the CA certificate of the of our Kubernetes cluster, and the client secret is a secret specific to this client. For example, this will be same for this cluster configuration will be same for scheduler, control manager, API server, etc, everything. But the client credential will be different for each client because it will be different credential and each client will have its own access based on the RBAC. Now let's inspect and see if this client credential is valid or not. So let me copy this client certificate data for the scheduler. Let me go into my mission. So this is a base 64 encoded format of a certificate. So let me do base 64 decode. So I got the certificate. Let me write the certificate into test.certificate. Right now I got the certificate. Let me try to understand the details of the certificate using OpenSSL inspect. So I do OpenSSL X509. The input is this test certificate. I want the output as a text format, and I don't want to print the certificate. So I am saying no output. So it's printing the output. Now, if we slowly see the details of the certificate, right, it is saying, okay, this is for the common name Kubernetes. I mean, it is issuer is the Kubernetes. Yeah, if we see the validity, it is May 25th to June 4 of 2023, but today is October 30. So which means the certificate is not yet valid, right, for the kube scheduler, right? Maybe if you want to see how it looks for control manager, let me copy the control manager. Let me copy the certificate. Here, let me do same thing, echo, copy the certificate, base 64, decode, write into controller.cert, OpenSL X509. Input is the controller cert, no out, text format output. If you see here for the controller manager, if you see the validity, it is like from August 30, not before August 30, and also it is valid for 1 year, 2024. So which means the scheduler config file, the client certificate has been expired. Now, how can we renew that expired to has been expired? How can we renew the certificate? So one more easy thing we can do, right? So this is based on the kind, which is again internally based on the KubeADM. So we have this KubeADM tool, which have a command called certs. So I can do KubeADM certs, check expiration. If I do that right, it prints for each component what are the expiry available. If you see for admin.conf, the expiry is still for 1 year, 2024. But if you see the scheduler conf, it is already expired and it is like June 4th. And some residual, it is invalid and it is signed by the proper CA, but it is not valid. So we have to fix this scheduler config. Now we can use the OpenSSL command to fix it. So also we have this KubeADM certs renew. We can use that command only. We can try to use that command, and we can say, okay, I want to renew scheduler.config file. I'm trying to give it, but if you see, it is failed to renew because the scheduler.config file is a it is failed to renew because the scheduler.config is having some issue with respect to the key. Key is not properly generated with the external key usage. Because I created the key, I didn't specify all the parameters required, because of which KubeADM is not able to renew this manually created certificate. So let's quickly manually fix this certificate. So in order to fix that, right, if I quickly show you how I broke the cluster in the first place right away, it'll help us to easily understand how to fix it. So let me open this, the create cluster with issue, and I'll show you how I created this cluster. Okay, if you see here, so basically in this one, I'm doing kind create cluster and wait for the nodes to be ready. Wait for the service accounts to be ready, similar as the previous things. And this time, what I'm doing, I'm getting the container IP and the container ID. Using the container ID, I'm doing exec into the container, and I am changing the date. So it is because when we do OpenSSL generate certificates, we don't have an option to specify the past dates. If I give past dates, the OpenSSL is failing, saying like you cannot create certificates for the past dates. So what hack I'm doing here, I'm doing like changing the date of my Kubernetes, the control plane, because I'm exec into the control plane. I'm changing the date of the control plane VM or the control plane container. I'm changing the date to something like an past date, 23 for the month of 5th. Then I'm creating a certificate. First, I'm creating a new key for the scheduler and new request to sign this certificate. I'm saying, okay, this is the username and this is the key usage and other things. And using that request, I'm signing that request with the CA certificate. This CA certificate is nothing but the CA certificate of the API server or our whole Kubernetes cluster. So which means if we sign this, if we have a CA certificate, and if you're able to sign it, and if we send that request to the API server, because this certificate is signed by this CA certificate, it will say, okay, I am authorized. This is signed by my CA certificate, so it will allow. So we are using that CA certificate and signing and getting the my scheduler, my cube hyphen scheduler dot certificate, and this is valid only for 10 days. Now using this certificate, and I'm resetting the clock back to the same time today. So which means if we change to today, this certificate is no longer valid, right? Now using that old certificate, I'm creating the kubeconfig file using kubectl config set cluster, set credential, set context. So we have a new kubeconfig file. Using that kubeconfig file, I'm replacing the existing scheduler config file, which is a valid, to the expired kubeconfig file. Then stopping the scheduler so that it immediately picks up the so I'm again using cricketl ps, the container ctl ps to get the scheduler, and then stopping the scheduler so that the scheduler once again restart, but this time it will see that, okay, there is a fresh uh, in that mount path, right? The volume mount path, it is a different value. It will take that and it will proceed, and it will say, okay, it's not a valid one. So I'm saying it will get an unauthorized error. So now, like, in order to fix that, right, we have to run the similar commands, but without changing the date, and then change this. So what I do in this create thing, I command the create part. So it will not create it, it will come here. I will command the date change part also. So date will not be changed, it will be using the same name. It may not be, it may not be needed, but doesn't matter because it's already sync. And I'm trying to create a cluster credential for 10 days. Yeah, let's try this. Yeah, in this case, it will not create the cluster. It will just exec into the cluster and fix the cluster. So let me do kubectl get pods now. It will take some time for the scheduler to be up and running. Let's check that. Yeah, it started, but it's still in 0/1. 11 seconds ago, it started. Let's see the logs of it. Yeah, if you see, now it got scheduled and it started running. Now, if you see the logs of this scheduler, it's been running successfully. It is able to talk to the API server using the credential. Now, let's do this. Let's check the expiry now. Kubeadium search check expiration. If you see now, for the scheduler, the expiry is 9 days it is available, because we put 10 days from today, it is like 9 days. So it's showing a proper expiry. So even after 9 days, it will get scheduled, it will get expired. We have to either rotate it like this, or we have to have an expiry similar to like 1 year and things like that. Yeah. So the main thing that I wanted to show in this episode is like there is no user data stored in Kubernetes. So Kubernetes use two ways of authentication. One is using the CA certificate. So if you're able to get create a OpenSSL request, OpenSSL key and a request and get it signed with the CA certificate, using that certificate, you can talk to the API server successfully. So you need a valid certificate signed by the CA certificate. And the CA certificate can have name and things like that. So you can look into these commands. Like if you see, I'm creating a new key. So the key does not have any data. It's just an encrypted key. Then I'm saying like using this key, create a new request for the user called system colon kube scheduler. And we can give extra details. So this is how certificate-based authentication is happening in Kubernetes. So So another way of doing authentication in Kubernetes is to give the authentication delegation to the external system like LDAP or AWS or GCP. I mean, whoever is having account in GCP or AWS, they can access this cluster. So which means that we can configure the API server in such a way that API server, whenever you get a request, talk to this external system, and if they say it is a valid certificate, then allow them access. So like that, we can configure our API server accordingly. And we have a special user called service account, which is again a special account used within Kubernetes cluster, or it can be used externally also. Recommended to use within Kubernetes cluster. For example, right, you deploy a microservice. That microservice want to talk to Kubernetes to say what are the other pods running, right? For example, some metrics based server. So you can create a service account, and you can specify this service account can only access pods, and that service account can be mounted to your microservice, so that your microservice will have access only to that access and can talk to the API server in which it is actually running. Yeah, so in a whole, right, this is how the final picture will look like. For the Kubernetes, you can use CA-based authentication or delegation to the external system, or the service account which is stored in the etcd. Again, the service account will have JW token, other things. You can look into more details in this blog post. Like this is my blog post, dineshba.github.io /Kubernetes users. You can, if you go to that list of dineshba.github.io, you can see list of blogs. In this one, there will be one page called "There is no users in Kubernetes." Basically, I am trying to say no user data is stored in Kubernetes. It's either external or the data is stored in the CA certificate, where the CA certificate is again held by the users. CA certificate will not get persisted in the Kubernetes API server or anywhere, or etcd anywhere. The users will hold the certificate. Yeah. For authorization, we spoke in the last time itself. We will be having roles, role bindings, cluster role binding. Using role and the user, we will be doing the binding, and that is how the permission is given to a particular user or a service account and things like that. Yeah. So we spoke about delegation. In order to create certificate, we can use OpenSSL, or there is another API in Kubernetes called a certificate. You can do kubectl certificate create CSR. Using the certificate itself, you should be able to, for example, right, if you see, you create an certificate signing request, and you are saying, okay, this is the request key, and this is the username, and this is the usage of this one. And using this one, create a new CSR, and it will be in pending state. And once the admin or somebody approves this one, the new certificate will be appended to this request. Now, using this request, you can create a new kubeconfig file, and then you can access the cluster. RBAC, we spoke about it. Yeah, RBAC is not only used for the users, it will be used internally also. Like kubescheduler will use RBAC to talk to the API server. So RBAC is used internally to the Kubernetes cluster, also for the external purpose and for the customer using purpose. So in this one, so in this blog, you can refer about how to use OpenSSL to create a new key request and sign it with the CA certificate for different components like scheduler, control manager, and things like that. Yeah, thanks everyone. If you like this video, if you found it useful, please like it, comment if you learned something from this video. Thank you.